Hello audience. Today we will discuss about the standard used for military electromagnetic compatibility, MIL 461. MIL Standard 461 is a United States military standard that describes how to test equipment for electromagnetic compatibility. The United States Department of Defense issued MIL 461 in 1967 to integrate electromagnetic compatibility into the research and development stage for defense communications technology. Various revisions of MIL 461 have been released. Many military contracts require compliance to MIL 461, Revision E. The latest revision, as of 2015, is known as MIL Standard 461G. While MIL 461 compliance is technically not required outside the U.S. military, many civilian organizations also use this document. MIL STD 461 Testing. MIL 461 provides the requirements for the control of electromagnetic interference emissions and susceptibility characteristics of electronic, electrical, and electromechanical equipment and subsystems designed or procured for use by activities and agencies of the Department of Defense, DoD. This standard is best suited for benchtop mounted or freestanding equipment, with a power input current draw of less than 200 amperes. It is not commonly applied to items such as components and independent modules located inside electronic enclosures, nor entire platforms such as an aircraft or submarines. However, the principles employed here may be useful as a basis for developing suitable requirements for any application. MIL 461 has been an active document since 1967 and has undergone several major revisions over the years. These changes were largely based on observed changes in a platform's electromagnetic environment caused by the rapidly increasing use of electronics and advancements in technology. Interestingly enough, legacy programs and retrofit activities may still refer to earlier versions of this document in order to ensure that there has been no impact since the original compliance report. Differences between the ways requirements are specified and test methodology as implemented in the military and commercial standards present challenges in making comparisons. These differences are treated in detail in the body of the guide. A summary of some of the aspects of various standards is discussed further. For military, MIL 461E specifies requirements and limits based on issues such as platform types, surfaces, ships, aircraft, etc., location, internal or external to structure, and unique platform features, anti-submarine warfare capability. Although tailoring of the requirements is encouraged for individual procurements, MIL 461E is structured to provide a reasonable set of default requirements if tailoring is not specified. It also provides standardized test methodology, which is consistent among the various requirements. There are setup conditions which are common to all the tests such as ground plane usage, electrical cable construction and routing, and power line treatment. For commercial, there are a variety of commercial standards which are considered in this guide. The most predominant are those set by the European Community. Others are Federal Communication Commission, FCC, Regulations and Radio Technical Commission for Aeronautics, RTCA, DO 160D, and the American National Standards Institute, ANSI. Now we will find out the differences between commercial and military standards. For orientation purposes, we itemize the most significant differences between commercial and military standards. Requirements in the very low frequency, VLF, range for submarines are unique because of critical dependence on the reception of sonar and VLF electromagnetic signals. There is a high concentration of electronic equipment aboard ships and other military platforms, including emitters and sensitive receivers. For this reason, military radiated emission limits are more severe than corresponding commercial limits. The military also places high immunity requirements on devices exposed to nearby intentional emitters. The general availability of grounded conducting surfaces, ground planes, for mounting equipment on military platforms. Most commercial equipment, when it is light in weight or portable, is mounted on an ungrounded tabletop. However, this difference is not pervasive. For example, floor-mounted commercial equipment is frequently bonded to a ground plane. Some frequency ranges are more extensive in military requirements than they are in commercial requirements, hence if an equipment is tested to meet commercial requirements, additional testing may be needed for military use. These differences make it impossible to find commercial qualified equipment that is completely equivalent to one meeting military requirements. This means that a detailed analysis is required to determine the adequacy of equipment tested to commercial requirements to meet the requirements of a particular military environment. Selection of commercial items for military use. In selecting commercial items, CI, for military purposes, one must relate the characteristics of the anticipated electromagnetic environment, EME, to the characteristics of the equipment under consideration. In order to determine whether a commercial item is adequate for a particular military application, it is necessary to determine which commercial standards are applicable to the equipment. Evaluate whether the commercial standards are adequate for the intended applications, and if not, to determine which additional requirements can be imposed, and what they are. Now we will discuss the changes and additions in MIL 461E from previous MIL standard versions. Equipment under test, EUT, hardware and software must now be representative of production units. Susceptibility scan rates have been revised. The frequency of measurement system test checks has been revised. CS 101 applicability has been extended to 150 kHz. CS 114 applicability has been rescinded to 200 MHz. CS 116 measurement procedures have been revised. RE 101 requirement at 50 cm has been deleted. An alternate RS 101 test using the Helmholtz coil has been added. RS 103 added the use of a mode-tuned reverberation chamber above 200 MHz. Position of sensor during RS 103 testing must be a minimum of 30 cm above ground plane. Some applicability designations for equipment installation location are changed. Military operating envelopes were modified for CS 114, RE 102, and RS 101 tests. The EMI test procedure, EMIDP, is one of the most important elements of a MIL STD 461 qualification program. It intended to organize the test methodologies used, define the test limits and levels, and explain how the equipment under test, EUT, will be operated, oriented, and electrically grounded during each test. It also provides a means to explain any tailoring activities or deviations from the MIL 461 standard requirements, as needed, in order to achieve agency approval prior to testing. Croydon Services is experienced working with product manufacturers to develop formal MIL 461 test procedures, and will assist you throughout the approval process. Thanking you.